The International Mathematical Olympiad doesn't really look like the Olympics you see on TV. There are no flaming torches, no running tracks, and no slow-motion replays of people throwing javelins, unless you count a number 2 pencil as a javelin, which in the wrong hands could probably still be dangerous. Instead of stadiums full of cheering fans, there's usually a quiet exam hall, and instead of athletes in colourful uniforms, you have teenagers in hoodies, clutching pens like they are ancient swords of wisdom. It's a strange sort of competition. For 2 days, the best young minds in the world sit in a room, thinking, and then they think some more. And after that, they might think a bit longer. Every so often, one of them will scribble something on paper, then stare into the distance as if they've just remembered a shopping list from 2003. It's not exactly the 100-meter dash, but trust me, in the world of mathematics, this is the big leagues. Now, imagine you're in that room. It smells faintly of coffee, pencil shavings, and quiet determination. The air is heavy with concentration, the kind of silence so thick you can hear the gentle scratching of graphite on paper. Somewhere a chair creaks, someone coughs. It feels like the entire planet is holding its breath while a group of teenagers wrestles with ideas older than their grandparents. And in one corner, glowing softly like a mysterious alien artifact, is ChatGPT 5, the shiny new AI everyone's been talking about. Is here to compete in the International Mathematical Olympiad. And no, it didn't arrive on a private jet or get smuggled in under a blanket. The organisers invited it, or maybe they didn't invite it exactly. Maybe they just wanted to see what would happen if you let the most advanced AI model in the world take on the most advanced human teenagers in the world. A friendly match, a meeting of minds. Although one of those minds lives on a server farm and occasionally crashes if you ask it too many questions about cheese. The funny thing is, this isn't even the first time math and machines have crossed paths. Humans have been building devices to help with numbers for thousands of years. The ancient Babylonians had clay tablets for counting, the Chinese had the abacus, and my personal favourite, in the 17th century a guy named Wilhelm Schickard invented what might have been the first mechanical calculator, but it caught fire before he could show it to anyone. Imagine spending years building a machine and then having to explain to your friends, well, it was amazing, but now it's mostly ash. Fast forward a few centuries and we've gone from abacuses to artificial intelligence. So advanced it can write essays, compose music, and pass law school exams. And now it's sitting here at the IMO, ready to solve problems that make normal people's brains melt like ice cream in July. But before you get the wrong idea, this isn't just a story about machines getting smarter. This is a story about people, and the funny, stubborn, brilliant ways we approach problems. You see, the IMO is not about speed. It's not about being able to multiply big numbers in your head faster than anyone else. If it were, ChatGPT 5 would have already taken home the gold before lunch. The IMO is about creativity, about coming at a problem from a weird angle no one else thought of, about staring at a question for an hour, getting nowhere, then suddenly realizing the answer was right in front of you, disguised as a triangle. And that's the tricky part for our AI friend. ChatGPT 5 can process 1 billion tokens and recall every math paper published in the last century, but it doesn't see problems the way humans do. Humans get hunches, they doodle in the margins, they come up with wild analogies, like comparing a difficult algebra problem to trying to untangle a set of headphones after they've spent 3 months in your pocket. Sometimes those leaps of intuition lead to nothing. Sometimes they lead to a breakthrough. But either way, they're uniquely human. I should also mention that while the IMO sounds glamorous in theory, in practice, it has the same energy as a long train ride. People shift in their seats, eyes wander. Someone is definitely thinking about lunch instead of geometry. And the coffee? It's usually lukewarm by the time you drink it. If the Olympics had a sport called staying awake while thinking hard about fractions, this would be it. Now the funny part is, ChatGPT 5 doesn't even need coffee. It doesn't get sleepy. It doesn't have a favorite pen. But that also means it doesn't get the joy of sharpening a pencil to a perfect point, or the satisfaction of finally solving something after your brain has been wrestling with it for hours. It just computes. And yet, in this competition, that might not be enough. As I look around the room in my mind's eye, I can almost see the contrast. On one side, a row of students from different countries wearing little badges with their flags, working with the intense focus of people who have trained for months for this. On the other, ChatGPT 5 metaphorically wearing a t-shirt that says, "I read the entire internet and all I got was this lousy problem set." It's the kind of matchup that makes you wonder, are we here to see if AI can beat humans, or to remind ourselves that humans are still worth rooting for? In a way, it feels like a spy thriller. There's an air of mystery. What will the AI do? Will it crush the problems with mechanical perfection? Will it stumble on a cleverly worded question? Will it try to answer a geometry problem with a haiku? Nobody knows, and that's why it's exciting. There's a saying in math competitions that the hardest part isn't the math, it's the nerves. For humans, anyway. I doubt ChatGPT 5 feels nervous. But it might be about to learn something humans already know. Sometimes the smallest twist in a question can turn a champion into a beginner again. And when that happens, it doesn't matter if your brain is made of neurons or neural networks, you have to stop, breathe, and think. So here we are, at the start of a very unusual International Mathematical Olympiad. In a few moments, the first problems will be handed out. The human contestants will glance at them, some will smile, some will grimace. ChatGPT 5 will silently process them at the speed of light. And somewhere in all this, we'll find out not just who's better at solving problems, but what solving problems really means. The International Mathematical Olympiad didn't just appear one day like a mysterious pop-up ad for the world's hardest quiz. It has a story. And like many good stories, it starts in the middle of the 20th century, when the world was in the mood for, well, competition, sports competitions, space competitions, and apparently math competitions too. The first IMO was held in 1959 in Romania. That's right, while the rest of the world was busy building rockets and arguing about who had the best jazz records, Romania decided it was time to gather a few brilliant teenagers and see who could solve the toughest math problems. It wasn't exactly front-page news in every country, but in math circles, it was like the moon landing. Well, maybe a slightly smaller moon, like a moon-shaped cookie. Back then, only 7 countries took part. Romania, Hungary, Poland, Bulgaria, East Germany, Czechoslovakia, and the Soviet Union. Yes, the whole thing started as a kind of friendly rivalry among Eastern Bloc nations. You can almost picture the opening ceremony, a few proud flags, some polite clapping, and a group of teenagers wondering if they were about to make history, or just spend 2 days regretting not studying combinatorics harder. The early years of the IMO were a lot smaller and quieter than today's sprawling events. For one thing, the problems were handwritten, and solutions were graded by actual people sitting at actual desks, probably with tea, biscuits, and the occasional heated debate about whether a step in a proof was obvious or suspiciously vague. There was no instant scoring system, no live stream, no AI judge quietly humming in the background, just paper, pencils, and pure brain power. And the problems. They were no joke. The very first IMO included a question about proving that a certain equation had no integer solutions. Sounds simple enough, right? Except that the trick was to spot a hidden structure that most people wouldn't notice if it jumped out wearing a neon sign. This was the kind of problem where you either had a flash of genius, or you spent an hour drawing tiny numbers in the margins, hoping they would form a pattern. Spoiler, they usually did. Over the decades, the IMO grew. More countries joined in, and soon it wasn't just Eastern Europe. By the 1970s, you had teams coming from Asia, Western Europe, and eventually the Americas. It became a truly international event, the United Nations of Math, except with fewer speeches and more proofs. The number of competitors swelled, the difficulty of the problems inched upward, and the prestige skyrocketed. Winning a gold medal at the IMO was like winning an Oscar. If the Oscars required you to spend 9 hours proving something about triangles, of course, as the competition grew, so did the quirks. There are legendary stories from past IMOs, like the year a contestant from one country accidentally fell asleep during the exam. They still managed to solve one problem perfectly, because apparently their brain was still doing math while they were dreaming. Or the time a translation error in one language made a problem slightly more confusing, leading to a flurry of hand-raising and whispered clarifications. There's nothing like asking for a definition of integer when you're supposed to be one of the best young mathematicians in the world. And then there are the math coaches. Each country sends not just students but also leaders, older mathematicians who are there to guide, encourage, and occasionally panic quietly in the corner. These coaches sometimes have the harder job because they can't actually help during the contest. They just have to sit there waiting to see if their students have that magic spark. Imagine being the parent of a marathon runner, but you're not allowed to give them water or shout advice. All you can do is smile nervously and hope they don't trip over the starting line. The IMO also has its traditions. One of the most famous is the way the problems are chosen. Countries submit potential questions months in advance, and then a jury of math experts debates which ones to use. These debates are apparently intense. I like to imagine them in a smoky room somewhere, although these days it's probably a conference hall with bad coffee. The jurors argue about whether a problem is too easy, too hard, or too similar to one from. Sometimes they even have to reject a problem because someone accidentally published it in a math journal 2 weeks earlier. Nothing kills the excitement like showing up to the biggest competition of your life and realizing you saw the question on page 14 of a newsletter. By the 1990s, the IMO was a global phenomenon in math circles. Countries sent their brightest stars, and those stars sometimes went on to become famous mathematicians, scientists, or tech innovators. Terence Tao, now one of the most celebrated mathematicians alive, was an IMO gold medalist at just 10 years old. That's right, while most 10-year-olds were still figuring out how to do long division without crying, Tao was out here casually winning international math competitions. And then there's the scoring. Each problem is worth 7 points, so a perfect score is 42, a number that, fittingly, is also the answer to the ultimate question. According to the Hitchhiker's Guide to the Galaxy, very appropriate for an event where some problems look like they were written by aliens with a fondness for geometry. But the IMO isn't just about the competition, it's also about the culture that forms around it. Students meet other math lovers from across the globe, swap stories, share puzzles, and sometimes invent new games to play during the downtime. There are tales of late-night hotel room problem-solving sessions, impromptu chess tournaments, and debates about whether a certain proof technique counts as elegant or just overcomplicated. It's like summer camp, but with more integrals and fewer mosquitoes. By the time we get to today, the IMO has a reputation for being one of the purest tests of problem-solving skill in the world. No calculators, no computers, no multiple-choice questions. Just you, a pen, a blank sheet of paper, and 6 problems that could either make your week or haunt your dreams. And into this grand tradition, this decades-long celebration of human ingenuity, walks ChatGPT 5, or perhaps more accurately, ChatGPT 5 is plugged in somewhere far away and sends its answers through a network connection. It's hard not to feel the weight of history here, from those humble beginnings in Romania with 7 countries to an event that now hosts contestants from more than 100 nations. The IMO has always been about pushing the limits of the human mind, and now for the first time we're asking if a non-human mind can play the same game, and what it might mean if it can. So as we sit here thinking about 1959, about teenagers in wool sweaters solving diabolical algebra problems under the watchful eyes of their coaches, it's strange to imagine this quiet revolution. Back then, the only thing that could crash in the competition was someone's ability to focus after too much strong coffee. Now, we might have to worry about whether the AI's server overheats, but that's the magic of the IMO. It's always been a place where the unexpected happens, where history gets written, not in grand speeches, but in neat lines of equations and diagrams sketched in pencil. And in this year's chapter of that history, the main character might just be a piece of code. Every competition has its wild card. In boxing, it's the unknown fighter who knocks out a champion in the first round. In cooking shows, it's the contestant who shows up with a secret family recipe for soup that makes the judges cry. And in this year's International Mathematical Olympiad, it's a chatbot. ChatGPT 5 didn't walk into the exam hall wearing a hoodie and carrying a lucky pen. It didn't shake hands awkwardly with the other contestants or glance nervously at the clock. Instead, it was somewhere far away, in a server room, humming along quietly, like a polite guest who insists on answering every question you ask, even the silly ones. How did it get here? That's a question with two answers. The short answer is, people wanted to see what would happen. The long answer is, this has been building for years, ever since AI started beating humans at things we thought were uniquely ours. Chess, Go, Jeopardy. It was only a matter of time before someone said, "All right then, let's see how you do with the International Mathematical Olympiad." The organisers didn't just throw a laptop into the competition and call it a day. They set up rules, made sure the AI was given the same problems as everyone else, and arranged for its answers to be submitted in the same style as the human contestants, which is trickier than it sounds because ChatGPT doesn't write with a pen. You can't just hand it a beak and expect it to doodle a diagram. Instead, it had to produce step-by-step proofs in text form, explanations clear enough for human graders to understand. This is actually harder than people think. A human student might make a tiny leap in logic and scribble, obvious in the margin. ChatGPT 5 has to spell out everything, because graders can't look into its digital brain to see if it really understood something or just got lucky. And if there's one thing we know about AI, it's that it can sometimes sound incredibly confident while being incredibly wrong, like that friend who insists they know the fastest route to the beach, but somehow you end up in a supermarket parking lot. The arrival of ChatGPT 5 at the IMO stirred up mixed feelings. Some people were excited. Finally, a chance to see how the latest AI stacks up against the best human problem solvers in the world. Others were skeptical. Is it fair? Is this even the same kind of thinking? And then there were the students themselves who reacted in the way teenagers often do. A mix of curiosity, competitiveness, and the occasional joke about cheating off the robot. You might think an AI has an unfair advantage. After all, it doesn't get nervous. It doesn't misread the question, because its brain is still replaying the awkward way it waved at someone in the hotel lobby. But AI has its own disadvantages. It doesn't have intuition. It doesn't have a sense of when to abandon one approach and try something totally different just because it feels right. And in math competitions, those instincts can make all the difference. It's worth pausing here to remember what ChatGPT actually is. It's not a calculator. It's not a database of every math solution ever written. It's a large language model, a system trained on vast amounts of text, designed to predict what words or symbols come next in a sequence. When it solves a math problem, it's not thinking in the human sense. It's generating a string of text that fits the patterns it has learned from millions of examples. That can lead to astonishingly good answers, but it can also lead to answers that are, well, creative in all the wrong ways. One of the quirks of ChatGPT is that it sometimes explains things as if it's narrating a bedtime story. I like to imagine it working on a geometry problem and saying, "Once upon a time there was a triangle who dreamed of being a square. That's charming, but it's not worth many points at the IMO." And this is where the real tension comes in. The AI has to produce solutions that are not just correct, but rigorous, elegant, and this is key, easy for a human to follow. Now, ChatGPT 5 isn't the first AI to try competitive math. Earlier versions of AI systems like AlphaCode or Minerva could tackle challenging problems from textbooks and research papers. But the IMO is different. The problems are fresh, never published before, and designed to be tricky in ways that mess with your head. They're built to test flexibility, creativity, and perseverance. It's like asking someone to solve a puzzle while the puzzle pieces keep changing shape. The day ChatGPT 5 was officially announced as a contestant, the math community lit up. Some saw it as the dawn of a new era, the point at which human and machine problem solvers could learn from each other. Others worried it would be the beginning of the end for competitions like this, where part of the charm is seeing how human minds wrestle with complexity. Personally, I think it's more like inviting a new player to a board game you've been playing for decades. At first, everyone's watching to see if they understand the rules. Then, if they turn out to be good, everyone's watching to see if they can be beaten. And of course, the jokes began immediately. Does ChatGPT get extra time if the Wi-Fi is slow? Will it write the answers in perfect calligraphy? If it wins, does it get a medal, or just an upgraded graphics card? Humor is how humans deal with change, even in math halls. For ChatGPT 5 though, this was just another prompt, another challenge to respond to. It didn't have stage fright. It didn't need a pep talk. It just needed the problems. And it would do what it always does, generate text until it ran out of things to say. Whether that text would earn gold or land in the nice try pile, no one knew. The human contestants, meanwhile, had their own reasons to be here. Some had been training for years, practicing past IMO problems like musicians practice scales. Others were naturally gifted problem solvers who thrived in the pressure cooker of competition. All of them were about to face the same set of 6 problems, and all of them knew that somewhere an AI was working on them too, and so the stage was set. In one corner, the collective experience and creativity of the best teenage mathematicians on the planet. In the other, a machine trained on more text than any one person could read in a lifetime. The match wasn't about strength or speed, it was about ideas, and whose ideas would shine the brightest when the dust settled. Of course, dust in this case is metaphorical. The IMO exam halls are very clean, but you get the idea. If you've ever tried to teach a human math, you know it's not always easy. Some people pick it up quickly, like a duck learning to swim. Others, well, it's more like trying to teach a duck how to juggle. Now imagine trying to teach math to something that doesn't even have a brain in the way we do. No feelings, no childhood memories of learning times tables, no joy when it gets the right answer. Just code. How do you do that? Well, the first thing to understand is that ChatGPT 5 doesn't know math in the same way you know math. If you ask it what 2 plus 2 is, it will almost always say 4. But that's not because it has an internal picture of 2 apples and another 2 apples, and then imagines 4 apples. It's because it's seen the phrase 2 plus 2 equals 4 about a gazillion times during training. It's pattern recognition, not apple recognition. So when you want to teach a robot math, you don't just give it a textbook and a pencil and hope for the best. You feed it enormous amounts of text that contain math. Equations, explanations, worked examples, proofs, entire archives of math competition problems and solutions. You let it see what correct math looks like, not once or twice, but millions of times. It's like raising a child by showing them every math book ever written, but also every conversation anyone has ever had about math. From serious research papers to the time someone posted online asking if 0 is even. For ChatGPT 5, this training data is the key. The more varied and rich the examples, the better it can mimic a mathematician's reasoning. But here's the tricky part. It doesn't actually do math the way a calculator does. A calculator has a built-in set of operations it can perform exactly, without error, every time. ChatGPT works differently. It predicts what should come next in a sequence of words and symbols. Most of the time, the next word is the right one. Sometimes, it's hilariously wrong. There's a term for when AI produces something that looks right but isn't. We call it hallucination. It's a fancy way of saying making things up with a straight face. Ask it to prove a theorem and sometimes it will, flawlessly. Other times it will invent a completely fictional theorem and prove that instead, with the confidence of someone explaining how they once fought off a bear with a spoon. The problem isn't that it's trying to trick you. The problem is that it has no sense of truth. It's just trying to sound plausible. That's why teaching math to a robot involves more than just giving it math to read. You have to give it ways to check itself. Developers train it to break down problems step by step, to slow down and verify answers, to compare multiple solution paths before deciding which one to output. It's a bit like teaching a student not to blurt out the first thing that comes to mind on a test, but to double-check their work before handing it in. One approach is called chain of thought prompting. This is where you tell the AI, don't just give the answer, show all the reasoning along the way. Imagine asking someone for directions to the train station, and instead of saying go left, they say first you'll pass the bakery, then the bookstore, then the fountain, and then you turn left at the corner with the big clock. That's what chain of thought does for math. It gives you the scenic route so you can see how it got there. Another technique is giving the AI access to actual math tools during training. For example, it might be allowed to call a calculator for exact arithmetic or a symbolic algebra system for tricky manipulations. Think of it like teaching a chef how to cook by giving them not just recipes but also a really good set of knives and a stove that actually works. Without those, they might still be able to describe how to make a cake, but the result would be theoretical. But even with all these tools, there's still a gap. Humans have an intuition about math that's hard to replicate. We can look at a problem and get a feeling for whether the answer will be big or small, positive or negative, elegant or messy. We sometimes skip straight to a clever trick because something in the problem just smells like it might work. ChatGPT 5 doesn't have a nose for that kind of thing. It has to grind through patterns until something fits. You might think this makes AI hopeless for math competitions, but in some ways it can be surprisingly good. It doesn't get tired, it doesn't panic, it won't misread a minus sign because it was daydreaming about pizza, and when it gets something wrong it can try again instantly. But the challenge is making it care, or at least simulate caring enough to produce solutions that aren't just correct, but well crafted. Interestingly, teaching AI math has taught us a lot about teaching humans math. The process of making an AI explain its reasoning clearly has parallels in education. Teachers have long known that when a student explains a concept out loud, they understand it better themselves. Likewise, forcing AI to talk through its math makes it more accurate, which means that in a weird way, we've been giving ChatGPT the same advice math coaches give teenagers. Slow down, explain your steps, and please, for the love of geometry, check your work. Of course, there are limits. You can't bribe AI with snacks to get it to study harder. You can't inspire it with stories about famous mathematicians who overcame great odds, or tell it that this competition could change its life. The only motivation it has is the parameters and objectives set by its designers. But in the hands of skilled trainers, that can be enough to make it perform impressively, sometimes even brilliantly, on problems that would stump many humans. So when ChatGPT 5 sits down, metaphorically, at the IMO, it's bringing with it not just raw computational power, but years of careful fine-tuning. It has been taught to reason step by step, to check its own logic, and to express its solutions clearly enough that a human grader might smile and say, yes, this makes sense. It has been trained not just to solve math, but to perform the act of solving math in a way that looks human. Whether that's enough to win a gold medal is another question. But one thing's for sure, it didn't get here by accident. Behind every line of code and every correct answer is a long process of teaching, testing, adjusting and teaching again. The people who trained ChatGPT 5 weren't just building a tool, they were, in their own way, coaching a competitor. And now, that competitor is about to face some of the trickiest, most devious problems that human minds can invent. Problems designed not just to test skill, but to push the limits of creativity. The kind of problems where the solution is a little like a magic trick, obvious once you see it, but invisible until then. In other words, the real question isn't just, can we teach a robot math? We've already done that. The question is, can we teach a robot to think like a mathematician? And in this competition, we're about to find out. It's funny how quickly humans have gotten used to competing with machines. A few decades ago, the idea sounded like pure science fiction. Machines were supposed to make coffee, not play chess better than grandmasters. They were supposed to print receipts, not write screenplays. And yet, here we are, in an era where it's normal to ask whether a robot could beat you at your favorite game, your favorite hobby, or in this case your favorite very, very hard math competition. The history of human versus machine contests is full of drama. One of the first big moments came in 1997, when IBM's Deep Blue defeated Garry Kasparov, the world chess champion. At the time, it felt like the end of an era. People said, well, that's it. Humans will never be the best at chess again. And in a way, they were right. But the interesting thing is, humans didn't stop playing chess. In fact, chess got more popular. People learned from the machines, and the machines learned from the people. It wasn't a war so much as a very intense, very nerdy dance. Then there was Go, an ancient board game that's so complex for years experts believed no machine could master it. The number of possible board positions in Go is larger than the number of atoms in the observable universe. That's not an exaggeration, that's just math being dramatic. But in 2016, AlphaGo, a program developed by DeepMind, defeated Lee Sedol, one of the best Go players in the world. And once again, people had to rethink the limits of human and machine. And then came Jeopardy! In 2011, IBM's Watson went up against two of the game's greatest champions, Ken Jennings and Brad Rutter. Watson not only won, it also made a few hilarious mistakes along the way, like buzzing in with an answer that made absolutely no sense in context. It was a reminder that while machines can process incredible amounts of information, they sometimes fail in ways no human ever would. The pattern in all these stories is clear. At first, humans are confident, then the machine wins, and everyone gasps. Then humans adjust, adapt, and keep playing. The rivalry becomes less about proving who's smarter, and more about pushing each other to new heights. And in the process, we discover that humans and machines think in profoundly different ways. That's why the IMO matchup between humans and ChatGPT 5 feels like the next chapter in a long tradition. It's not about replacing human mathematicians. It's about curiosity. Can an AI trained on text solve problems that stump the best teenage problem solvers on the planet? And if it can, does that change how we think about math or about ourselves? The thing about math competitions is that they're not purely about logic. They're about personality too. Humans bring quirks to the table. One contestant might doodle little stars in the margins when they're thinking. Another might hum quietly while working through a geometry proof. A third might decide to completely ignore the obvious approach and instead try something wildly creative, just to see if it works. Sometimes it does, sometimes it's a disaster. But either way, it's interesting. ChatGPT 5, on the other hand, doesn't have quirks in the same sense. It won't doodle, it won't hum, it won't go off on a wild tangent just because it feels like it. The closest it gets to personality is when it decides to explain something in a slightly unusual way, because its training data happen to lean in that direction. That's one of the odd charms of AI. It's like talking to someone who has read everything ever written but still can't tell a joke without sounding like they're reading it off a cue card. But that's also where the rivalry gets interesting. In some cases, the AI's lack of intuition is a disadvantage. In other cases, it's an advantage. A human might be led astray by a misleading diagram, or a word that makes them think of the wrong technique. The AI doesn't get misled in the emotional sense. It just evaluates all the possibilities it can see, and goes with the one that seems to work best according to its internal scoring. It's cold, efficient, unsentimental, which is, ironically, sometimes exactly what you need. There's also the question of stamina. Humans get tired. After 3 hours of problem solving, most contestants are ready for a nap, a snack, and maybe a small existential crisis. The AI doesn't get tired. It doesn't need break. If you gave it 100 problems in a row, it would just keep going, spitting out solutions until the server room ran out of electricity. But humans have resilience of a different kind. A human can get stuck on a problem for an hour, feel frustrated, walk away, and then suddenly have the answer pop into their head while they're brushing their teeth. The AI doesn't have those moments of sudden insight triggered by a change of scenery. It either figures it out on the spot, or it doesn't figure it out at all. That's why this rivalry feels less like a boxing match and more like a strange collaboration where the two sides aren't allowed to talk to each other. Both have strengths the other doesn't. Humans can leap intuitively. AI can grind through possibilities with relentless patience. Humans can spot beauty in a solution. AI can spot patterns across billions of examples. Put them together, and you might get something extraordinary, but in the IMO, they're separate. The challenge is to see who does better on their own. Some people imagine this as a Rocky-style showdown, man versus machine, winner takes all, but the reality is quieter. The human contestants will sit in their chairs, scribbling, erasing, thinking. ChatGPT 5 will quietly generate proofs in some distant server, oblivious to the fact that it's even competing. The rivalry exists entirely in our heads, in the way we interpret the scores at the end. And maybe that's the point. The real drama isn't in the moment-to-moment action. It's in the meaning we attach to it. If the AI wins, does it mean machines are better at math than people? Or does it mean that math is broad enough for multiple kinds of intelligence to succeed? If the humans win, does it prove the superiority of human creativity? Or does it just mean the AI needs a little more training? Whatever the outcome, this rivalry is friendly in the sense that no one's going to lose their job or their dignity over it. But it's also serious in the sense that it asks deep questions about what it means to solve something. Is solving a math problem purely about getting the right answer? Or is it also about the journey, the thought process, the little sparks of joy when something clicks? For humans, the journey matters. For AI, the journey is just a means to an end. That difference is why we keep staging these contests. We want to see the contrast. We want to see the machine do something amazing. And we want to see the human do something even more amazing in a completely different way. So here we are once again, watching humans and machines face off. It's not the first time, it won't be the last. And as long as both sides keep surprising us, we'll keep coming back for more. Every competition has rules. You can't just show up to a tennis match with a golf club and say, I'm going to try something new. You can't enter a cooking competition and start serving raw spaghetti with ketchup, unless you want the judges to cry. And you definitely can't walk into the International Mathematical Olympiad and say, I've decided to answer all the questions in interpretive dance. Well, you could, but you probably wouldn't score very many points. The IMO rules are simple on the surface, but like everything in math, the details matter. The whole event takes place over 2 days. On each day, contestants get 3 problems. Just 3. Sounds easy, right? It's not. Each problem is worth 7 points for a maximum score of 42. Yes, 42. The same number that Douglas Adams' Hitchhiker's Guide to the Galaxy famously called the answer to the ultimate question of life, the universe and everything. Whether that's intentional or just a cosmic coincidence, I'll let you decide. You get 4.5 hours each day to work on your 3 problems. That's an hour and a half per problem if you divide it evenly. But here's the twist. Most people don't solve all of them. These aren't straightforward find X questions. These are deep, sneaky, clever puzzles designed to make you sweat, stare at the ceiling, and wonder if math is even real. The average person might spend the whole 4.5 hours just trying to make a dent in one. The problems are chosen carefully. A committee called the Problem Selection Committee gathers months in advance to review submissions from countries all over the world. Each participating nation can submit proposed problems, but they have to be original. No recycling from old contests. No rewording something you saw in a math blog. The committee debates each one. Too easy? Out. Too similar to a past problem? Out. Too impossible? Out. Unless it's impossible in a beautiful way, in which case they might keep it just to see what happens. Once the problems are chosen, they're kept secret until the day of the exam. They're translated into dozens of languages for the contestants. This can be tricky. There have been cases where a small translation error made a problem more confusing, and nothing causes more collective groaning in a math hall than realizing you've been wrestling with a phantom difficulty caused by a misplaced word. When the clock starts, contestants work in silence. You can bring a ruler, a compass, and pens or pencils, but no calculators, no books, no internet, and definitely no ChatGPT in your pocket. That's why ChatGPT 5's entry into the competition is unusual. It can't sit in the same room. It can't follow the no internet rule. It is the internet in a sense. So the organizers have to simulate fairness by giving it the problems at the same time as everyone else, and making sure it produces solutions in the same format. Now, what makes the IMO different from many other tests is that partial credit is a big deal. If you make progress toward the solution but don't finish, you can still get points. Maybe you set up the problem beautifully, but don't close the final step. You might get 5 points instead of 7. Or maybe you have a brilliant idea but your algebra is a disaster. You might still earn something. This encourages creativity. Even a failed attempt can be valuable if it shows insight. That's an important distinction for ChatGPT 5. A wrong answer with no work gets nothing, but a wrong answer with a fascinating approach could still get points. The graders are mathematicians themselves, and they appreciate elegance, originality, and effort. In fact, there's a long-standing joke among IMO veterans. Write something that makes the grader smile, and you've already scored a point. Of course, that doesn't work if your grader is an AI, but that's another story. The problems themselves fall into a few categories: algebra, combinatorics, geometry, and number theory. Algebra problems might involve equations that look innocent until you realize they're hiding a monster inside. Combinatorics problems ask you to count things in a way that makes your brain twist sideways. Geometry problems lure you in with a nice diagram, then quietly ruin your day. Number theory problems. Well, number theory is the branch of math where people get excited about remainders and prime numbers. So you can imagine, one of the more charming traditions of the IMO is that each problem has a certain flavor. Some are elegant. A single clever trick unlocks the whole thing. Others are endurance tests. Long, grinding slogs where you have to be methodical and stubborn. The best problems have a bit of both. They reward creativity and persistence, like a safe that needs both the right combination and a lot of turning. The scoring happens after the contest, with solutions anonymized so graders don't know whose paper they're marking. Each solution is reviewed by multiple graders to make sure the score is fair. Sometimes there are disagreements. Was that last step really valid? Did the contestant prove what they think they proved? These debates can get surprisingly heated. People care about precision in math, and in the IMO, precision is everything. For ChatGPT 5, the challenge isn't just solving the problems, it's presenting the solutions in a way that satisfies human graders. It can't just say answer 17 and walk away. It has to write a coherent proof, logically structured with each step justified. In other words, it has to play the human game. And that's what makes this year's IMO so fascinating. On paper, the rules are the same for everyone. Same problems, same time limit, same scoring. But the reality is that humans and AI approach those rules from completely different worlds. A human contestant might spend 20 minutes just thinking about which problem to tackle first. The AI might start all three at once, working in parallel. A human might take a break to stare out the window, hoping inspiration will strike. The AI doesn't have windows, or breaks, or inspiration for that matter. Still, the magic of the IMO is that it doesn't care how you think, only that you can produce a correct and convincing solution. It's the great equalizer. Whether your mind runs on neurons or silicon, the problems are the same, the solutions are the same, and the points, well, the points are the same too. So here we are. The stage is set. 6 problems over 2 days. 42 possible points. More than 100 of the brightest young humans in the world. And one AI that's read more math than anyone in history. The only thing left is to see who plays the game better. Every competition has rules. You can't just show up to a tennis match with a golf club and say, "I'm going to try something new." You can't enter a cooking competition and start serving raw spaghetti with ketchup unless you want the judges to cry, and you definitely can't walk into the International Mathematical Olympiad and say, "I've decided to answer all the questions in interpretive dance." Well, you could, but you probably wouldn't score very many points. The IMO rules are simple on the surface, but like everything in math, the details matter. The whole event takes place over 2 days. On each day, contestants get 3 problems. Just 3. Sounds easy, right? It's not. Each problem is worth 7 points, for a maximum score of 42. Yes, 42. The same number that Douglas Adams' Hitchhiker's Guide to the Galaxy famously called the answer to the ultimate question of life, the universe and everything. Whether that's intentional or just a cosmic coincidence, I'll let you decide. You get 4.5 hours each day to work on your 3 problems. That's an hour and a half per problem if you divide it evenly. But here's the twist. Most people don't solve all of them. These aren't straightforward find X questions. These are deep, sneaky, clever puzzles designed to make you sweat, stare at the ceiling, and wonder if math is even real. The average person might spend the whole 4.5 hours just trying to make a dent in one. The problems are chosen carefully. A committee called the Problem Selection Committee gathers months in advance to review submissions from countries all over the world. Each participating nation can submit proposed problems, but they have to be original. No recycling from old contests, no rewording something you saw in a math blog. The committee debates each one. Too easy? Out. Too similar to a past problem? Out. Too impossible? Out. Unless it's impossible in a beautiful way, in which case they might keep it just to see what happens. Once the problems are chosen, they're kept secret until the day of the exam. They're translated into dozens of languages for the contestants. This can be tricky. There have been cases where a small translation error made a problem more confusing, and nothing causes more collective groaning in a math hall than realizing you've been wrestling with a phantom difficulty caused by a misplaced word. When the clock starts, contestants work in silence. You can bring a ruler, a compass, and pens or pencils, but no calculators, no books, no internet, and definitely no ChatGPT in your pocket. That's why ChatGPT 5's entry into the competition is unusual. It can't sit in the same room. It can't follow the no internet rule. It is the internet in a sense. So the organizers have to simulate fairness by giving it the problems at the same time as everyone else, and making sure it produces solutions in the same format. Now, what makes the IMO different from many other tests is that partial credit is a big deal. If you make progress toward the solution but don't finish, you can still get points. Maybe you set up the problem beautifully, but don't close the final step. You might get 5 points instead of 7. Or maybe you have a brilliant idea, but your algebra is a disaster. You might still earn something. This encourages creativity. Even a failed attempt can be valuable if it shows insight. That's an important distinction for ChatGPT 5. A wrong answer with no work gets nothing, but a wrong answer with a fascinating approach could still get points. The graders are mathematicians themselves, and they appreciate elegance, originality, and effort. In fact, there's a long-standing joke among IMO veterans: write something that makes the grader smile, and you've already scored a point. Of course, that doesn't work if your grader is an AI, but that's another story. The problems themselves fall into a few categories: algebra, combinatorics, geometry, and number theory. Algebra problems might involve equations that look innocent until you realize they're hiding a monster inside. Combinatorics problems ask you to count things in a way that makes your brain twist sideways. Geometry problems lure you in with a nice diagram, then quietly ruin your day. Number theory problems. Well, number theory is the branch of math where people get excited about remainders and prime numbers. So you can imagine one of the more charming traditions of the IMO is that each problem has a certain flavor. Some are elegant. A single clever trick unlocks the whole thing. Others are endurance tests, long, grinding slogs where you have to be methodical and stubborn. The best problems have a bit of both. They reward creativity and persistence, like a safe that needs both the right combination and a lot of turning. The scoring happens after the contest, with solutions anonymized so graders don't know whose paper they're marking. Each solution is reviewed by multiple graders to make sure the score is fair. Sometimes there are disagreements. Was that last step really valid? Did the contestant prove what they think they proved? These debates can get surprisingly heated. People care about precision in math, and in the IMO, precision is everything. For ChatGPT 5, the challenge isn't just solving the problems, it's presenting the solutions in a way that satisfies human graders. It can't just say answer 17 and walk away. It has to write a coherent proof, logically structured, with each step justified. In other words, it has to play the human game. And that's what makes this year's IMO so fascinating. On paper, the rules are the same for everyone. Same problems, same time limit, same scoring. But the reality is that humans and AI approach those rules from completely different worlds. A human contestant might spend 20 minutes just thinking about which problem to tackle first. The AI might start all three at once, working in parallel. A human might take a break to stare out the window, hoping inspiration will strike. The AI doesn't have windows, or breaks, or inspiration for that matter. Still, the magic of the IMO is that it doesn't care how you think, only that you can produce a correct and convincing solution. It's the great equalizer. Whether your mind runs on neurons or silicon, the problems are the same, the solutions are the same, and the points, well, the points are the same too. So here we are. The stage is set. 6 problems over 2 days. 42 possible points. More than 100 of the brightest young humans in the world. And one AI that's read more math than anyone in history. The only thing left is to see who plays the game better. There's something almost cinematic about an unexpected comeback. In sports, it's the underdog team suddenly scoring 3 goals in 5 minutes. In movies, it's the quiet side character pulling off the impossible. And in this year's IMO, it was ChatGPT 5 delivering a solution so perfect, so elegant, that even the most skeptical graders raised an eyebrow and muttered, "Okay, that's actually good." The problem in question was the second one of the day. On paper, it looked harmless. A geometry puzzle, cleanly stated, with a neat little diagram. Geometry problems are the polite dinner guests of the IMO. They arrive looking simple, they smile warmly, and then they quietly dismantle your sanity while you're not paying attention. This one involved circles, tangents, and an angle chase. The kind of thing where you can see exactly what the final picture should look like, but getting there is like trying to assemble a jigsaw puzzle where all the pieces are slightly the wrong shape. For a lot of contestants, geometry problems are either a favourite snack or a sworn enemy. There's no middle ground. The human contestants took their usual approaches. Some started by redrawing the diagram on fresh paper, carefully marking all the known lengths and angles. Others stared at the original drawing for a long time, hoping some hidden symmetry would reveal itself. A few went straight into full-blown proof mode, writing lines of equations without even looking up. ChatGPT 5, of course, didn't see the diagram in the human sense. It had the problem description in text form. Instead of visualizing a picture, it turned the words into relationships between points, lines, and angles. In its own alien way, it was reconstructing the diagram in a high-dimensional mental space made of tokens and probabilities. No pencil, no compass, no satisfying click of a ruler, aligning perfectly. Just math. Pure and cold. And here's the thing. That coldness worked in its favor this time. Humans sometimes overthink geometry problems. They get fixated on making the picture look nice, or on proving something they think must be true, even if it's not directly related to the question. ChatGPT 5 didn't have that kind of bias. It followed the given relationship step by step, linking one property to the next like climbing the rungs of a ladder. And at some point, somewhere in that invisible space of symbols, it hit upon the key lemma that unlocked the whole thing. Now, a lemma, for those who haven't lived in the math world long enough to collect one, is like a mini theorem. It's a smaller fact you prove on the way to proving the main thing you're after. In geometry, lemmas are often the quiet heroes. Once you prove the right one, the rest of the problem falls apart in minutes. Humans know this. AI knows this. But the AI doesn't get distracted by the 50 other lemmas it could try along the way. ChatGPT 5's write-up was beautiful. That's not a word mathematicians throw around lightly. It was concise without being vague, clear without being pedantic. The steps flowed naturally, each one building directly on the last, until the final statement emerged with the inevitability of a sunrise. No unnecessary flourishes, no it is obvious shortcuts, just a clean chain of reasoning from start to finish. When the graders saw it later, they didn't have to argue about points. It was full marks straight away, and for a moment there was a collective pause, the kind of pause people take when they realize they might have underestimated someone or something. Word travels fast in competition circles. By lunch, the human contestants had no official idea how anyone else had done. The rules forbid discussion during the contest, but whispers of the AI nailed problem 2 were already circulating in the subtle ways competitors communicate without words. Raised eyebrows, a tiny shrug, a look that says, "Yeah, I think it solved it." One contestant during the post-lunch break admitted quietly to their coach that they were curious to see the AI's solution when it was all over. "If it's as good as they say, I might actually learn something," they said. And that's one of the quietly fascinating outcomes of all this, competition or not. Good solutions have a way of inspiring everyone. It's worth noting that AI elegance is a strange thing. ChatGPT 5 didn't intend to be elegant. It wasn't thinking, yes, I'll impress them with my succinct argument. Elegance is a human judgment, an emotional reaction to the clarity and efficiency of a solution. But even without intending it, the AI had stumbled into producing something that humans found aesthetically pleasing. That says something about the overlap between how we solve problems and how a well-trained AI solves them. There's common ground, even if the journeys are different. Of course, not everyone was impressed. A few die-hard skeptics rolled their eyes. "Sure, it got this one," they said. "Geometry's easier for machines than combinatorics or number theory. Let's see how it does on something really tricky." Skepticism is healthy in math. It keeps you from believing things too quickly, whether those things are proofs or headlines. But for most people watching, and for me telling you this now, this was the moment when ChatGPT 5 stopped being a novelty act and started being a real contender. The first problem of the day had been a mixed bag for it, with some shaky reasoning. But the second, that was a statement, a way of saying, I can play this game, and I can play it well. Humans and machines think differently. But in that moment, looking at the AI's perfect geometry proof, you could almost forget which was which. It was just a good piece of mathematics, standing on its own, independent of who or what had written it. And in the end, that's one of the strange beauties of math. A proof is a proof, no matter whose brain or server it came from. As the afternoon wore on, contestants shifted their attention to the third problem of the day, which loomed like a mountain on the horizon. The AI, having dispatched problem 2 with surgical precision, moved on without celebration or relief. For humans, solving a problem often comes with a burst of energy, a smile, maybe even a quiet fist pump under the desk. For ChatGPT 5, there was none of that. No emotional reward, just the next challenge. But that's what made this moment so compelling. Here was a machine that couldn't feel pride, yet had done something worthy of it. And here were humans feeling that pride on its behalf, or at least feeling the thrill of seeing something done exceptionally well. By the end of day 1, no one knew exactly where the standings were, but everyone, humans, graders and the AI's own handlers, knew that the contest had just gotten a lot more interesting. Day 2 of the IMO always feels different. The adrenaline of the first day has worn off. Everyone knows now that the problems are real, not hypothetical monsters in the distance. but actual monsters you've already fought with for hours. Sleep comes in fragments. Breakfast is either wolfed down in nervous haste or skipped entirely because your stomach's staging a protest. And when you sit down for round two, you're not thinking I'm going to win gold. You're thinking, let's just survive this. For ChatGPT 5, of course, there was no difference between day 1 and day 2. No tired eyes, no sore hands, no lingering mental fog from the geometry marathon. It was just another set of problems, another prompt to respond to. But for the human contestants, the mood was serious. They'd seen, or at least heard, what the AI could do. And for some of them, that wasn't intimidating. It was motivating. The first problem of the second day was a combinatorics puzzle. Combinatorics is, in simple terms, the art of counting things when counting them directly would take longer than the age of the universe. These problems are beloved by some and feared by others. To the untrained eye, they look like harmless arrangements of objects. To those who know better, they are minds disguised as flowers. This particular problem had a playful surface, arranging colored tokens under certain rules, but beneath it was a brutal network of constraints. It was the kind of problem where one wrong assumption early on means hours of wasted effort. The AI attacked it the way it attacked everything, systematically, logically, without fatigue. It laid out the known facts, applied standard counting techniques, and started generating casework like a machine, because, well, it is one. And for a while, it looked like it might just power through. But here's the thing about combinatorics. It rewards a certain kind of flexible, creative leap. Humans are messy thinkers. We zigzag, we guess. We try things that seem unrelated just to see what happens. And sometimes that zigzagging lands on an insight that clean logic alone might never stumble into. One human contestant, let's call her Elena, spotted something within 20 minutes that the AI would completely miss. It was a symmetry hidden deep in the problem, a way to cut the counting in half without losing information. It wasn't the kind of trick you find by grinding through cases. It was the kind you find by playing with the problem, by letting your brain wander and make connections it can't quite explain yet. Once she saw it, the rest fell into place like dominoes. The long, tedious enumeration the AI was slogging through simply wasn't necessary. In just under 2 hours, she had a complete, correct solution. And not just correct, elegant. The graders later said they would have used her method as the official model solution in the marking scheme. Meanwhile, ChatGPT 5's solution was fine. It worked, eventually. But it was long, clunky, and lacked that snap of insight. It was like watching someone open a door by picking every single lock, one after another, while Elena had just leaned over and found the spare key under the mat. And Elena wasn't the only one. Across the room, a contestant from South Korea found a completely different shortcut, a clever way to reframe the problem so it became a much simpler one in disguise. Another competitor from Brazil spotted a pattern in the numbers that pointed directly to the answer. Humans, as it turned out, weren't just keeping pace with the AI, they were outpacing it, at least on this problem. When the solutions were graded later, the humans dominated. Several scored full marks. ChatGPT 5 got its points too, but without the kind of style that gets mathematicians excited. This was a win for Team Human, no question. It's worth pausing to think about why. The AI wasn't wrong in any critical sense. It had the right answer. But in a competition like the IMO, speed matters because it frees you to work on the harder problems. If you take the scenic route every time, you run out of time. Humans who spotted shortcuts could bank those minutes and spend them on the trickier parts of the day's set. And here's another thing. The human methods had character. They reflected individual ways of thinking, preferences for visualizing, for experimenting, for reframing. They were fingerprints in proof form. The AI's solution was more like a very neat, very careful printout of someone else's work, functional but impersonal. By lunchtime, the mood among the human contestants had shifted. Day one's quiet awe at the AI's geometry masterpiece had given way to a kind of playful defiance. Yes, the machine was strong. Yes, it could produce impressive work, but it wasn't unbeatable. Not here. Not in a field where creativity could outflank brute force. There's an old saying in chess: the threat is stronger than the execution. In math competitions, you could adapt it to say, the insight is stronger than the calculation. Humans are good at insight. We get flashes of it in the shower, on the bus, in the middle of dinner. We don't always know where it comes from. But when it comes, it changes everything. And that's what happened on day two. Problem by problem, the humans reminded everyone, and maybe even reminded themselves, why the IMO exists. It's not just to crown a winner. It's to celebrate the many different ways a mind can wrestle with a challenge. Some of those minds are built from neurons, some from silicon, but there's a particular joy in seeing the neuron-based ones pull off something the silicon-based one didn't. Of course, ChatGPT 5 didn't know it had been beaten on problem 4. It didn't feel disappointment or the sting of a lost point. It just moved on to the next task. But for the humans, there was satisfaction, not the kind that makes you arrogant, but the kind that makes you sit a little straighter and think, we're still in this. By the end of day 2, no one knew the final scores yet, but if you'd been watching closely, you could sense it. The humans had landed a solid punch. And in any friendly rivalry, that's when things get really fun. There's a strange kind of quiet that settles in after the last problem of the day is handed in. It's not the peaceful quiet you get after a good nap or a nice long walk. It's the kind of quiet that happens when 200 people have collectively been squeezing their brains for 9 hours over 2 days, and now there's nothing left to squeeze. The contestants file out of the exam hall slowly, like marathon runners who aren't entirely sure their legs still work. Some head straight for the snack table, others wander outside, blinking in the sunlight, like they've just emerged from a cave. There's laughter, there's muttering, there's the occasional "I can't believe I missed that," said to no one in particular. For ChatGPT 5, there's no tired shuffle, no stretch of the shoulders, no rush toward food. It doesn't eat, it doesn't walk. When the last problem was solved, or at least when its last proof was generated, it simply stopped. The work was done. Now it was in the hands of the graders. The graders are the unsung heroes of the IMO. They're the ones who take stacks of handwritten solutions, and in this case neatly typed AI-generated text, and comb through them line by line. They check each step. They argue over interpretations. They give partial credit where it's deserved, and they cross out points where a tiny logical gap opens into a canyon. Grading at the IMO isn't fast. Each country's leaders grade their own students' papers first, but the final scores have to be agreed upon by the central jury. This means there's a lot of back and forth. Is this step enough for 3 points? Or is it worth 4? Do we consider this a valid proof? Or does it rely on something they didn't actually show? It's as much diplomacy as it is mathematics. And so, after a day or so of intense marking, the first unofficial whispers start to circulate. Not the full scoreboard, but just enough to fuel speculation. Apparently ChatGPT got full marks on the geometry problem. I heard a student from Vietnam got 42. No, the AI messed up a number theory problem, that's what I heard. The truth is, the mid-competition rumour scoreboard is more folklore than fact, but in a way it's part of the fun. Contestants swap stories, each one slightly warped from the last, until you've got half the room convinced that someone proved Fermat's last theorem during the lunch break. Still, there's always a general sense of the standings before the official list comes out, and this year that sense was, well, tense, from what people could piece together. ChatGPT 5 was doing well, very well. It had nailed a couple of the harder problems in a way that impressed even the graders. But it had also stumbled, not catastrophically, but enough to leave room for the humans to keep pace. Several human contestants were right there alongside it, in total points. The phrase neck and neck started getting thrown around. For the humans, this was good news. Not because they wanted to defeat the AI in some grand symbolic way, Most of them were more focused on their own medals than on making headlines, but because it meant the competition was still wide open. There's nothing worse than feeling like the gold is already out of reach before the final tally. For ChatGPT's human handlers, the researchers and engineers who had fine-tuned it for this contest, the mood was more analytical. They pored over its mistakes, trying to see patterns. Did it tend to falter on problems that required a big leap of insight? Did it handle clean, structured problems better than messy, open-ended ones? In a way, this was as much an experiment for them as it was a competition. Some observers couldn't resist turning it into a sports-style rivalry narrative. Headlines in the imaginary Math Olympics daily might have read, "Man versus machine, locked in a tie at halftime. Humans strike back as AI fumbles the tokens problem. 42 possible points, infinite bragging rights." Of course, there was no halftime show, no marching band, just a few side events and excursions for the contestants. Trips to local landmarks, cultural activities, maybe a chance to relax by a river or in a park. These are some of the nicest moments at the IMO, when the pressure lifts and you see the contestants laughing together, swapping puzzles, or playing card games that inevitably turn into probability debates. ChatGPT 5 naturally skipped the excursions. It wasn't invited, but even if it had been, what would it do at a museum? Read all the descriptions faster than anyone else, and then stand awkwardly in the gift shop? Machines don't do sightseeing, but in a way, it was out there in the world, in the conversations people had about it, in the curiosity it sparked, in the mental comparisons everyone was making between how it worked and how they worked. The most interesting part of the neck-and-neck moment was that it didn't make anyone complacent. The humans knew they had to push hard in the remaining problems. The AI's handlers knew it could still make a surprising leap. And the graders? Well, the graders just wanted to get through the mountain of scripts without losing their sanity. By the end of the mid-competition phase, one thing was clear. This was not going to be a runaway victory for anyone. The IMO, for all its intensity, had become a balanced, almost poetic contest between two kinds of intelligence. Neither was perfect. Both had strength, and the outcome would come down to just a few crucial problems. And that's why, even without a scoreboard in front of them, everyone could feel the same subtle electricity in the air. The competition wasn't just alive, it was thriving. The IMO is often described as intense, high stakes, even dramatic. But if you walked into the competition hall in the middle of a contest, you might think you'd wandered into a particularly focused library. No one's running, no one's shouting, and no one is swinging a giant foam finger in the air yelling, "Go number theory." Instead, it's quiet. Quiet enough to hear the sound of a pencil pausing mid-stroke. Quiet enough to hear the soft thunk of an eraser being pressed into paper. Quiet enough that if someone coughs, 30 heads turn automatically. It's the kind of quiet that isn't just about politeness. It's about concentration. Every contestant in that room is deep in their own private world. A world made of angles and inequalities, primes and patterns. The outside world doesn't exist for those few hours. Lunch doesn't exist. Your phone doesn't exist. The only thing that exists is the problem in front of you, and your own brain trying to make sense of it. For the human contestants, this quiet is a double-edged sword. On one hand, it's perfect for thinking. No distractions, no small talk. On the other hand, it's so quiet that you become hyper-aware of yourself. You notice your handwriting getting messier. You notice your heartbeat when you realize your brilliant idea just fell apart. You notice that the contestant 2 seats over has been writing non-stop for 20 minutes, and you haven't written a thing. The mind is a strange creature. It can calculate the trajectory of a comet, but it can also spiral into panic because you sharpened your pencil too many times. And in one corner, metaphorically speaking, there's ChatGPT 5, existing in a very different kind of quiet. No ticking clock it can hear. No fidgeting neighbours. No awareness that others are working faster or slower. It's just input and output. The steady hum of processors turning problem statements into solutions. The silence for the AI isn't a tense stillness. It's simply the default state. The beauty of this behind-the-scenes stillness is that it's where the magic actually happens. From the outside, solving a math problem looks like nothing. Just someone sitting there staring at paper. But inside, there's movement. Ideas are circling, colliding, rearranging themselves. It's like watching the surface of a calm pond while a whole ecosystem thrives underneath. Every problem solver has their own rhythm in this quiet. Some start fast, filling the page with diagrams and notes. Others just stare, holding the entire problem in their head before committing anything to paper. Some pace the room when allowed, like chess players walking away from the board. A few even close their eyes for long stretches, looking for patterns in the dark. And the funny thing is, some of the best breakthroughs come from doing nothing at all, at least nothing visible. A contestant might be slumped in their chair, seemingly defeated, when suddenly they sit up, grab their pen, and write a single line that changes everything. That's the nature of problem solving. It can be 90 minutes of wandering in a fog, followed by 30 seconds of clarity. Of course, not every moment in this quiet is a genius moment. There's also boredom, there's frustration, there's the part where you think, well, maybe I'll just try this random approach even though I know it's wrong, because doing something feels better than doing nothing. Sometimes that random approach actually works. Sometimes it digs you into an even deeper hole. ChatGPT 5 doesn't have that restless energy. It doesn't get bored. It doesn't doodle little spirals in the margins. It doesn't invent weird side problems just to keep itself entertained. But in a way, that's also its limitation. The human brain's wandering nature, the part that jumps sideways and makes strange connections, is sometimes the very thing that finds the solution. One of the quietest moments in the hall is when someone finally reaches an answer. They don't shout. They don't high-five the person next to them. They just sit there, maybe leaning back for a second, rereading what they've written to make sure it's all correct. It's a private victory, and then it's back to work on the next problem. Graders often say they can see the story of a contestant's thinking in their paper. There are false starts, crossed out pages, sudden changes in approach. You can see where someone hit a wall, and you can see where they broke through it. Sometimes those breakthroughs are neat and tidy, other times they're messy, but they still work. That's the human touch. The AI's papers, if you can call them that, tell a different kind of story. There's no mess, no false starts, at least not in the printed version. Just a clean stream of reasoning from beginning to end. Of course, behind the scenes, the AI did try different approaches internally, but you never see that on the page. You just see the final polished product. It's like reading the last draft of a novel without seeing the notes, the edits, or the scrapped chapters. And that's why this quiet matters. It's not just the absence of noise, it's the space where thinking happens, where ideas evolve. It's a kind of invisible labor that most people never get to watch, because it's, well, invisible. There's an old saying among mathematicians, mathematics is not a spectator sport. That's true in the sense that you can't watch someone's thoughts the way you can watch a football game. But if you could see inside the minds in that room, human or machine, during those silent hours, you'd realize it's as competitive, as intense, and as alive as any stadium. And maybe that's why, for those who love it, the quiet of problem solving is addictive. It's the place where you meet yourself at your sharpest and your most puzzled, sometimes at the exact same moment. It's the place where frustration turns into insight, and where an empty page slowly becomes a story worth telling. If you've ever wondered what goes on inside ChatGPT 5's head during a math competition, the answer is, well, complicated. For one thing, it doesn't really have a head, no eyes to glance at the problem, no fingers to twirl a pencil, no heart to start pounding when the clock ticks louder than you'd like. But it does have something, an internal machinery that processes problems in a way that's completely alien to human thought. And yet, if you squint, you can find echoes of our own reasoning in there. Here's how it works in broad strokes. When the AI receives a problem, it doesn't read it the way you and I read. It turns the text into tokens, little chunks of data, each representing a piece of language. These tokens are fed into a massive neural network, layer after layer, like passing a note through a very long hallway full of people who each add a scribble before passing it on. Every layer transforms the information slightly, picking up on patterns, connections, and possible next steps. Some layers are good at spotting relationships between numbers. Others are tuned for logical structure. Others handle the way sentences are phrased. Eventually, all of this comes together into a kind of probability map of what the next token should be. And then the next, and the... To a human, this can sound oddly mechanical, because it is. ChatGPT 5 isn't thinking in the human sense. It's predicting. It's guessing the most likely continuation of the text it's already generated, given the patterns it has learned from billions of examples. But here's the twist. Those billions of examples include a lot of math, past competition problems, academic papers, forum discussions where someone tried to explain modular arithmetic to a stranger at 2 a.m. All of that gets baked into the AI's intuition. In a way, this thinking process is like playing the world's largest, most complicated game of autocomplete. Except instead of finishing your text message with "sounds good," it's finishing a proof of why a certain geometric configuration must have equal angles. The AI doesn't get stuck the way humans do. It doesn't stare into space or sigh when a promising approach fizzles out. Instead, if one chain of reasoning seems to lead nowhere, it can pivot instantly, starting a new chain without the emotional baggage of having wasted time. In that sense, it's ruthless. But it's also limited. It doesn't have the same kind of subconscious percolation humans rely on, that mysterious process where your brain keeps working on a problem in the background while you do something else. Another difference. Humans often solve problems in big leaps. We hold an idea in our minds, something half-formed, maybe not even fully explainable, and then suddenly it clicks, and we jump 3 steps ahead. ChatGPT 5 doesn't leap. It builds its answers brick by brick, with each brick placed because statistics say it's the best brick to place next. The result can be solid, but sometimes it's missing that spark of sudden, almost magical insight. That doesn't mean the AI is unimaginative. In fact, sometimes it produces steps that look surprisingly creative. This happens when the patterns it's learned from different problems combine in unexpected ways. A technique from a number theory problem showing up in a combinatorics proof, for example. To us, that looks like originality. To the AI, it's just probability aligning in an unusual but effective way. When you read one of its solutions, it can feel eerily human. It uses familiar phrases, "let us assume," without loss of generality. It follows that. It sets out its logic neatly, with numbered steps or clearly separated cases. But if you look closely, you might notice subtle quirks. It might over-explain something no human competitor would bother with, just to make sure it's covering every possible doubt. Or it might skip a justification, because in its statistical world, that step has always been obvious, even though a grader might not agree. And here's something funny. The AI doesn't know when it's done. Humans feel that rush of closure when the final line of a proof lands, the "yes, that's it" moment. ChatGPT 5 just stops, because it has decided the probability of any new useful token is low enough that it's time to end. It's not satisfaction, it's just a mathematical threshold being crossed. During the IMO, ChatGPT 5's thoughts were invisible to everyone. No scribbles, no muttered ideas, no glances up at the clock. Just input, process, output. And yet, behind that digital curtain, there was a kind of strange parallel to what the humans were doing, breaking a big problem into smaller ones, chaining steps together, checking for consistency. One of the organizers later said that reading the AI's scripts felt a little like grading an extremely polite student who had never once been late with homework, never once left a page messy, but also never once made a joke in the margin or drawn a tiny smiley face next to a correct answer. It was all very formal. And maybe that's the main difference between human and AI thinking in math. Human thought leaves fingerprints, traces of personality, preference, and even mood. AI thought leaves patterns perfectly aligned, evenly spaced, but without the warmth of a living hand. Still, as the competition went on, some graders admitted quietly, so as not to start a philosophical debate over the coffee table, that there was something impressive, even humbling about the consistency. If you gave this thing enough problems, one said, I think it could pass for one of our top students, until you asked it what its favourite number was, and it gave you a 500-word essay on why numbers can't have personal relationships. At the end of the day, ChatGPT 5's thinking process might not be thinking in the human sense, but it gets results, and in a competition like the IMO, results matter. Whether those results come from a quiet human brain in a silent hall, or from a server farm humming away half a continent away, the proof, quite literally, is in the proof. If the IMO were just about following rules, machines would win every time. They're built for it. No distractions, no cutting corners, no I'll come back to this later procrastination. They just do the thing. Give a machine the rules, and it will follow them down to the last comma. Humans, on the other hand, are terrible at following rules consistently. We break them, we bend them, we forget them halfway through, and then remember them just in time to rewrite half our work. And somehow, here's the strange part, that messiness is often our advantage. You see, human creativity in math is a bit like jazz. Sure, there's structure, there's theory, there's a key signature, but the best moments happen when someone plays a note that technically doesn't belong. And it works. Machines don't really do jazz. They play the score exactly as written. If they ever hit a wrong note, it's not because they were exploring, it's because they tripped over a bug. During the IMO, you could see this difference in real time. On one particularly nasty number theory problem, ChatGPT 5 took the direct route. It translated the problem into formal steps, applied the standard tools, and pushed forward with mechanical precision. No deviation, no detour. The result was neat and logical, but it didn't actually reach the finish line. Somewhere in the middle, the path it had chosen simply didn't connect to the answer. Meanwhile, one of the human contestants, let's call him Raphael, did something no machine would have considered. He guessed, not blindly, but in that weird human way where you look at a problem and think, I don't know why, but I feel like this number might be special. He tested a few examples, spotted a pattern, and then reverse engineered a proof from the ground up. To an AI, that's backwards. Proof comes first, examples second. To Raphael, it was just how his brain wanted to play with the idea. And here's the kicker. Raphael's method worked beautifully. His paper was a little chaotic, arrows pointing between lines, margins crammed with side calculations, one step crossed out so hard you could practically hear the eraser squealing. But the heart of it was solid. When the graders pieced it together, they gave him full marks. That's the thing about human creativity. It's not linear. It loops, it wanders, it stumbles into answers sideways. Sometimes you find the solution while explaining the problem to a friend. Sometimes it pops into your head while you're thinking about lunch. Machines don't do that. They can't wander unless you tell them exactly how. But machine logic has its own quiet power. Where humans get bored or sloppy, machines stay steady. They never forget a definition halfway through. They never accidentally use the wrong theorem because they were daydreaming. They can check every possible subcase without sighing, and that can be a huge advantage, especially on problems where thoroughness beats inspiration. One example from this IMO was a combinatorics problem with so many moving parts that most humans ran out of patience long before the end. ChatGPT 5 didn't. It handled the grind with perfect calm, ticking off every subcase like a meticulous accountant. It didn't get clever, but it didn't need to. The slow, steady logic was enough to get the full score. So in a way, human creativity and machine logic are like two tools in a toolbox. Sometimes you need the scalpel of AI precision. Sometimes you need the sledgehammer of human intuition. The magic and the drama of the IMO this year came from seeing those two tools side by side, each shining in different moments. Of course, when you put the two approaches next to each other, the differences become stark. A human solution might have a little story hidden in it. You can almost imagine the moment they saw the key insight. An AI solution feels like a carefully edited Wikipedia page. Correct, well-structured, and slightly impersonal. One grader, after a long night of marking, put it perfectly. The humans give you a map of how they got there. The AI gives you the finished building. Both are impressive, but only one lets you see the construction process. And maybe that's why, even if AI someday matches or surpasses humans in raw problem-solving ability, people will still care about the human way of doing math. Because math isn't just about answers, it's about the journey, the false starts, the flashes of insight, the moments where you go from confusion to clarity in a single breath. That messy, emotional arc is part of what makes it satisfying. Machines don't feel that arc. They just arrive. And if they overshoot the answer, they don't get embarrassed. They just adjust. There's no frustration, no relief, no joy. Just process. But here's where it gets interesting. In some problems, you can actually combine the two. A human might use intuition to guess the right direction, then let a machine grind through the tedious details. Or an AI might present a structured proof that inspires a human to see a shortcut. This IMO didn't allow for collaboration, but you couldn't help thinking about what would happen if it did. In a way, that's the future a lot of mathematicians imagine. Not man or machine, but man and machine, each covering the other's blind spots. The creativity of one, the consistency of the other, the leaps and the ladders. If you love math, that idea isn't threatening, it's exciting. Still, this year's IMO wasn't about collaboration, it was about comparison. And as the competition moved into its final problems, both sides had shown what they could do. The humans had dazzled with elegant tricks and unexpected insights. The AI had impressed with clean logic and unshakable persistence. The scoreboard was still tight. The mood in the hall was focused. And somewhere quietly humming away in a server room, ChatGPT 5 was getting ready for the problem that would decide everything. Every IMO has one. That one problem people will talk about years later. The one that splits the scoreboard in two, turns medal hopes upside down, and makes you wonder if the problem committee secretly enjoys watching people suffer. This year's that problem arrived on the second day, right after lunch. On paper, it didn't look intimidating. No wall of equations, no obscure notation that makes you check the glossary. Just a deceptively short statement. The kind that makes you think, how bad could it be? Very bad, as it turned out. The problem was a number theory puzzle dressed up in simple clothes. It involved divisibility, sequences, and a mysterious condition that seemed harmless until you tried to work with it. It was the kind of problem where you could understand every single word of the statement and still have no idea where to start. The humans read it once, twice, a third time just to make sure they hadn't missed some hidden clue. A few optimists started scribbling ideas. The more cautious ones sat back and stared at the ceiling, the way people do when they're trying to summon wisdom from the fluorescent lights. ChatGPT 5 got the problem at the same time. And here's where the machine style usually shines. Clear statement, formal setup, attack with standard techniques. But this problem wasn't standard. It had a trap, a subtle one. The obvious first approach led into a maze of subcases that seemed promising for a while, but eventually hit a dead end. Humans noticed this because they felt the dead end approaching. They could sense that the path was getting tangled, that the work was growing without leading anywhere. ChatGPT 5 didn't feel that. It just kept going, and going, and going. It built a towering argument of perfect logic on a foundation that didn't connect to the actual solution. On the page, it looked like progress. To a grader, it would eventually look like a very neat way of getting absolutely nowhere. Meanwhile, a few human contestants were making progress, but not in straight lines. One of them, a student from Ukraine, decided to ignore the obvious approach entirely and try something unconventional, playing with small examples. They wrote out sequences for small numbers, tested the condition, and started noticing a pattern. It wasn't proof, but it was a hint. From that hint came a conjecture, a guess about the general case, and from that conjecture came the first correct path to the solution. It wasn't easy. The proof still required careful reasoning and some clever lemmas. But now there was a destination in sight. Another contestant from Canada found a completely different entry point. They noticed that the condition could be rewritten in a way that made it look like a problem about remainders, something number theory veterans know is often a better lens to look through. That reframing opened a door no one else had seen, and within an hour, they too had a complete correct proof. The room stayed quiet, but if you knew what to look for, you could spot the breakthroughs, the slight shift in posture, the faster movement of the pen, the quiet satisfaction of a line drawn confidently, instead of tentatively. For the students who cracked it, this was their moment. For those still stuck, it was a long, frustrating climb, and ChatGPT 5, still deep in its self-assured maze, blissfully unaware that there was a faster way. It eventually circled close to the truth, almost by accident, but without the critical insight to lock it in. The proof never closed. In competition terms, that meant partial credit at best. This was the turning point. Up until now, the AI had matched or outpaced the humans in several problems, but here, raw processing power wasn't enough. The problem rewarded those flashes, chef's inspiration that come from a mix of intuition, experience, and playfulness, qualities that don't emerge from statistical pattern matching in quite the same way. By the end of the session, the difference was clear to anyone watching the grading. The humans had scored big here, not all of them. This was a hard problem, even by IMO standards, but enough of them to shift the balance, and the AI, for all its earlier brilliance, had stumbled at exactly the wrong moment. Later, when the problem was discussed in the jury room, one of the committee members smiled knowingly. "We put that in to test creativity," they said. "You can't grind your way to the finish on this one. You have to see it." And that's exactly what had happened. The people who saw it were mostly human. It's tempting to frame this as a grand human triumph moment, but that's too simplistic. Yes, the humans had taken the lead here, but it wasn't because they were universally better. It was because this problem played to their strength. Swap it for a different one, something more suited to exhaustive case analysis or formal manipulation, and the story might have gone the other way. Still, for the contestants who nailed it, the feeling was electric. There's nothing quite like solving the problem, the one that everyone will remember. They'd tell the story for years, how they spotted the trick, how the proof came together, how they walked out of the hall, knowing they'd just had one of the best moments of their mathematical lives. And for ChatGPT 5, well, it didn't walk out. It didn't feel disappointment. But its handlers noticed. They marked this as a weakness, something to study, not to fix in a competitive sense, but to understand, because understanding why a machine misses something humans catch is just as valuable as the reverse. The scoreboard wasn't final yet, but after this problem, the shape of the competition had changed. The gap between the top humans and the AI had widened just enough to make the ending uncertain, and that's what made the last problems and the final scores so much more interesting. If you've ever been in a math competition, you know there's a special kind of pain in realizing you've made a mistake. Not at the end, not halfway through, but at the beginning. It's the intellectual equivalent of building a skyscraper, only to find out you poured the foundation on a giant trampoline. Humans do this all the time. We misread a problem, we mix up a definition, we forget that 0 is in fact an even number. The difference is, when we catch the mistake, we feel it. There's a sting, a flash of "oh no," then a frantic scramble to fix it before time runs out. ChatGPT 5 had its own "oh no" moment this year, although being a machine, it didn't actually feel it. And that's part of what made it so fascinating. The problem in question was the last one on the final day. A tricky combinatorics challenge involving arrangements with a peculiar set of restrictions. It wasn't the hardest on the paper, but it had enough moving parts to trip up anyone who wasn't paying close attention to the exact wording. And that's exactly where the AI slipped. The condition was subtle. It excluded a particular type of arrangement, but only under a very specific scenario. Most humans, after a careful reading, realized the condition didn't apply universally. They highlighted it, circled it, or made a little note in the margin that said something like, "Watch this." ChatGPT 5 did. Instead, it treated the condition as if it applied in every case. That one misinterpretation at the very start cascaded through the entire solution. Every count it made, every subcase it considered, every careful line of reasoning, all of it was built on the wrong premise. And because the AI doesn't stop to ask itself, wait, does this make sense in the same way a human does? The error went unchecked. From the outside, the write-up looked flawless. Clean logic, no contradictions, no sudden leaps. If you didn't know the problem statement, you might have thought it was a model answer, but the graders knew. And the graders, bless them, have a job that's part mathematician, part detective. They trace the logic back, step by step, until they hit the moment of divergence, the exact point where ChatGPT 5 had made the incorrect assumption. In human terms, this is like rewinding a movie to find the scene where the main character made the one decision that ruined everything. The result? 0 points. Not because the AI hadn't worked hard, if you can call it working, but because every step was answering the wrong question. And at the IMO, no matter how pretty your proof is, if it's proving the wrong thing, it's a no-go. Humans, of course, make this mistake too. But here's the difference. In a competition hall, a human might catch themselves halfway through. They might think, wait, that can't be right. Go back and reread the problem. The AI didn't have that meta-awareness. It didn't think about whether its own approach matched the intent of the problem. It just kept going because the internal machinery said this was the most probable path. One of the graders described it later in the cafe. It was like watching a master chef make a perfect cake with salt instead of sugar. The technique was flawless. The result was inedible. The irony is that ChatGPT 5 could have solved this problem correctly. All it needed was to pass that one condition with a touch more nuance. In fact, a few human contestants who took the machine-like route, systematic enumeration of cases, did solve it, because they noticed early on that the condition didn't apply everywhere. But here's where the human advantage showed again, reading between the lines. Humans don't just parse a problem for its literal meaning. They also think about why the problem is worded that way. We get suspicious of oddly specific conditions. We ask ourselves, what are they trying to hide here? It's not that we're paranoid, okay? Maybe a little. But that curiosity sometimes catches the subtle traps. ChatGPT 5 didn't have suspicion. It had tokens and probabilities. And in this case, they pointed confidently in the wrong direction. This blunder didn't sink its entire competition run. It had already racked up strong scores on other problems, but it was a big hit. Enough to put the top human contestants safely out of reach, assuming they didn't make their own catastrophic mistake in the final grading. For the audience following along online, the story of the problem the AI misunderstood became an instant favourite. There's something inherently satisfying and a little comforting about seeing a machine trip over something so human-like as a reading comprehension error. It reminded everyone that for all its brilliance, ChatGPT 5 wasn't infallible. And for the contestants, it was a morale boost. If the AI could make that kind of mistake, so could they. And that was okay. It wasn't about being perfect. It was about being good enough, often enough to stay in the running. After the competition, some of the AI's developers admitted they'd learned as much from that one failure as from all its successes. In the world of machine learning, mistakes are gold mines. They tell you exactly where the blind spots are. And this one, misunderstanding nuanced conditional rules, was a blind spot worth studying. In the end, Error in the Matrix wasn't just a funny headline for the math forums. It was a reminder of what the IMO is really testing. Not just the ability to crunch through logical steps, but the ability to see the problem clearly from the very start. If you miss that, it doesn't matter how fast you run, you're running in the wrong direction. There's a particular hush that falls over the IMO hall when it's time for the results. Not the quiet of problem solving where the air is thick with concentration, but the quiet of waiting. The papers have been marked. The disputes have been settled. The graders have drunk enough coffee to keep a small city awake for a week. Now it's time to see how the whole thing turned out. The scoreboard is a simple thing, just a list of names, countries, and total points, but it carries the weight of weeks, months, sometimes years of preparation. For some, it's the culmination of their high school math career. For others, it's just another step in a lifelong love affair with numbers. For ChatGPT 5, it's, well, data. Ones and zeros in a spreadsheet. The organizers always take their time revealing the scores. It's not to be cruel, at least not entirely, but to savor the moment. After all, the IMO isn't just about numbers, it's about stories. The student who came from a tiny rural school and stunned everyone, the returning contestant who improved by 20 points, the country that took home its first gold medal in decades. And this year, of course, there was the biggest story of all, the AI competitor. People leaned forward as the announcer began reading. Bronze medals first, a ripple of applause for each name. Then silver, more applause. Some students beamed, others nodded quietly, proud but clearly eyeing the next tier. Then, gold. This is where the tension peaks. Gold medalists at the IMO are a rare breed, and this year everyone wanted to know, would ChatGPT 5 be among them? It was. When its name, or rather its label, was read aloud, there was a murmur through the crowd. It wasn't shock exactly. The AI had proven it could compete at the top level, but hearing it officially called a gold medalist made it real. A machine had stood on equal footing with the best young mathematicians in the world, but it wasn't first. That honor went to a human, a 17-year-old from Vietnam, who had scored a near-perfect paper, missing only a single point on a brutally hard problem that had stumped almost everyone else. The audience erupted in applause. The winner grinned sheepishly, as if embarrassed by the noise, and accepted the medal with both hands. ChatGPT 5 came in third overall, edged out by not only the Vietnamese champion, but also a contestant from Ukraine who had nailed the problem that changed everything. Its total score was still remarkable, enough to put it ahead of hundreds of human contestants, but not enough to claim the top. And somehow, that made the story even better. If the AI had won outright, the headlines might have been about machines replacing human brilliance. Instead, the narrative was more nuanced. A machine could compete, yes, but it wasn't invincible. Humans still had their moments. Big, brilliant, unrepeatable moments, where insight beat calculation. The announcer continued down the list. Each name met with cheers from friends, teammates, and sometimes even competitors. One of the nicest traditions at the IMO is that applause is never stingy. Everyone knows what it takes to get here. Everyone knows the hours of practice, the pages of mistakes, the sheer stubbornness required to wrestle with math at this level. Whether you score 42 points or 14, you've earned respect. ChatGPT 5's medal was collected, symbolically of course, by one of its developers. They stood there in front of the crowd, smiling a little awkwardly, the medal draped over their arm. It was a strange sight, a human holding a medal for a machine, but it worked. The applause was genuine. After the ceremony, the scoreboard stayed up for a while, giving everyone a chance to see the final breakdown. Students clustered around, pointing out scores, congratulating each other, occasionally groaning at a 1 point away near miss. And inevitably there were the what-ifs. What if I hadn't wasted so much time on problem 2? What if I'd spotted that trick earlier? What if the AI hadn't misread that one condition? But that's part of the magic of competitions like this. The results are final, but the conversations go on forever. For ChatGPT 5, there was no post-mortem reflection, no bittersweet pride, no sense of I almost had it. But for its human handlers, there was plenty to think about. The competition had revealed strengths, speed, consistency, vast knowledge, and weaknesses, nuance, creative leaps, the ability to reinterpret a problem statement midstream. All of those would become data points for the next iteration. And for the humans in the room, the results carried a quiet reminder. Math isn't just about getting the answer. It's about how you get there. The scoreboard measures points, but it doesn't measure the joy of a breakthrough, the satisfaction of a clean proof, or the thrill of finding a shortcut no one else saw. As the hall slowly emptied, the scoreboard dimmed, and the medals clinked softly in their boxes, there was a feeling that something special had just happened, not just because of who won, but because of the way the competition had unfolded, human and machine side by side, pushing each other to their limits. In the years to come, people would remember the 2025 IMO for many things. The Vietnamese champion's near-perfect score, the Ukrainian contestant's elegant solution to the turning point problem, and of course the first time an AI walked away with a gold medal, and the first time it learned that gold doesn't always mean first. The medal ceremony was over. The applause had faded, and the contestants were milling about in that pleasant, slightly dazed state that comes after a big event. This is the part the organisers call media time, which sounds glamorous but usually just means a couple of folding chairs, a camera on a tripod, and someone with a clipboard asking questions. First up was the new IMO champion, the 17-year-old from Vietnam. Soft-spoken, a little shy, but with the calm confidence of someone who knows they've just done something extraordinary. When asked how he felt about winning, he shrugged and said, "I'm happy," but the geometry problem was still annoying. That's a very IMO thing to say. Victories are nice, but the real obsession is the one problem that could have gone cleaner. He explained that he had been practicing 6 hours a day in the months leading up to the competition, mixing old IMO problems with new ones. His coach wrote specifically to stretch his creativity. "I tried to solve them without looking at the hints," he added, which is basically the mathematician's equivalent of lifting weights without a spotter. Risky, but it makes you stronger. The second place finisher, the Ukrainian student who had cracked the problem that changed everything, was in a more talkative mood. "I just like weird problems," she said, grinning. "The ones where you think, this can't be solved." And then she admitted that during the competition, she'd been tempted to peek at another problem when she got stuck, but she forced herself to stay on it. It's like staring at one of those magic eye pictures. At first you see nothing, then suddenly there's the image, and then came ChatGPT 5's interview. Obviously the AI couldn't sit in a folding chair, so one of its developers stood in as its spokesperson, reading out pre-generated answers the AI had given when asked about its performance. "Kyo, ChatGPT, how does it feel to win a gold medal at the IMO? A. I do not have feelings. However, the probability of this being a satisfactory outcome for my developers is high." There was polite laughter from the room. Q. What was your favorite problem? A. My highest scoring problem was the second geometry question. It demonstrated optimal alignment with my training data. The Ukrainian medalist whispered to the Vietnamese champion, "That's a very boring way to say geometry is fun." He nodded. "Q. Any regrets?" A. Regret is a non-applicable human construct. However, my misinterpretation of the combinatorics condition on problem 6 produced suboptimal results. This will be addressed in future iterations. The spokesperson paused after that one, as if hoping the AI might spontaneously develop a sense of humor. It didn't. The most amusing moment came when a journalist, clearly unable to resist, asked the AI, "Do you think you could beat yourself next year without missing a beat?" The developer read, "Statistically, however, the variance in problem selection and my lack of improvement through human-like intuition make prediction intervals wide." It was, in its own way, a perfect IMO answer. Correct, precise, and slightly incomprehensible to the casual listener. Between interviews, the champions mingled. The Vietnamese winner asked the AI's developer whether ChatGPT ever made silly mistakes on purpose, just to see what would happen. No, the developer replied, but it does make them accidentally, and we pretend it's a learning opportunity. The Ukrainian contestant suggested, half joking, that next year they should let the AI compete in the team round. It would be funny to see if it could keep up with 4 humans arguing in 3 different languages about the same diagram. The developer looked thoughtful, which in tech circles usually means we might actually try that. One of the most touching interviews was with a contestant from a small Pacific Island nation who had scored just enough for an honorable mention. She said, "I know I won't win a medal, but I solved one of the hardest problems, and for me that's everything." That's the other side of the IMO, the victories no scoreboard can measure. By the end of the day, the champions were tired but still glowing. The journalists had enough quotes to keep the math blogs busy for weeks, and ChatGPT-5's handlers had a neat little data set of post-competition statements. It's strange, really. Interviewing a machine, you can't catch it off guard. You can't make it smile. You can't ask it about its childhood, because it didn't have one. But you can still learn something from the way it answers. You see its priorities, you see how it frames success and failure, and you realize that, for all the differences between silicon and neurons, the core challenge in math is the same. Look at a problem, understand it deeply, and find a way through. The Vietnamese champion said it best when someone asked him what advice he'd give to next year's contestants. He thought for a moment, then said, "Don't worry about who you're competing against. Worry about whether you've understood the problem. That's the real race." Even ChatGPT-5 might have agreed with that. Statistically speaking, of course, competitions end. The medals are packed away, the chairs are stacked, the hall is swept clean. But the lessons, those stick around, they sneak into your thoughts on the bus ride home, or while you're brushing your teeth, or when you're lying in bed wondering if there was a shorter proof for problem 3. This year's IMO, with its human champions and its silicon newcomer, left behind more than just a scoreboard. It left a kind of blueprint for the future, not just of math competitions, but of how humans and machines might learn from each other. For the humans, the lesson was clear. Creativity still matters. The problems that separated the top from the rest weren't necessarily the ones that required the most raw calculation. They were the ones that rewarded a sideways leap, a reimagining of the question, a bit of intellectual mischief. Machines can grind through complexity, but they don't wake up in the morning with a hunch that the answer might be hidden in an unexpected corner. One of the coaches put it bluntly, "If you want to beat an AI, don't try to be an AI. Try to be weird." It sounds like bad advice for a job interview, but in the context of a math competition, it's perfect. The IMO isn't a factory. It's an art gallery disguised as an exam hall. The best solutions often have a touch of the unexpected, like a brushstroke that makes the whole picture come alive. For ChatGPT-5, the lessons were different, though technically it didn't learn them in the human sense. Its developers did. They saw where the model excelled: structured reasoning, recall of obscure theorems, the patience to enumerate every single subcase without blinking. And they saw where it stumbled: interpreting subtle conditions, spotting when a promising path was actually a dead end, connecting dots that weren't already statistically linked. One developer described the competition as stress testing intuition. Humans have it, machines simulate it. Sometimes the simulation is good enough to pass for the real thing. Sometimes it isn't. This IMO gave them a whole catalogue of cases where the simulation broke down. Interestingly, both sides seemed to take something from the other. Humans saw the value of persistence, of systematically checking every possibility instead of abandoning a path because it felt wrong. And the AI's team saw the value of playfulness, of trying small examples, even silly ones, just to see what happens. There was also a shared takeaway: clarity matters. Many of the AI's struggles, and quite a few human mistakes, came down to reading the problem statement too quickly, or assuming it meant something it didn't. In the quiet aftermath of the competition, you could almost hear the collective sigh of "next time I'll read it twice." Beyond the technical lessons, there were softer, more philosophical ones. For the humans, it was a reminder that competing isn't just about winning. Most of them wouldn't remember their exact scores in 5 years, but they would remember the people they met, the late-night practice sessions, the thrill of seeing a path open up in a problem that had seemed impenetrable an hour before. For the AI's developers, it was a reminder that mathematics is more than a sequence of logical steps. It's a conversation between the problem and the solver, between intuition and rigor, between the messy human mind and the tidy world of formal proof. ChatGPT 5 could participate in that conversation, but not in the same way a human could. It didn't have a personal stake, or a sense of beauty, or the quiet pride of knowing it had wrestled something difficult into submission. One of the older mentors who had competed decades ago summed it up over dinner. It's not the medal that matters, it's knowing you've met something bigger than yourself and done your best against it. This year, that something bigger happened to be part human, part machine. And maybe that's the real takeaway. The future of math isn't a battle between people and algorithms. It's a partnership. Even if right now, the partner can't high-five you when you solve a problem. The IMO this year wasn't the end of anything. It was the beginning of a new kind of story. The final irony. For all the noise about the AI, the most viral moment online wasn't its perfect geometry proof or its misread combinatorics problem. It was a blurry cell phone video of 2 contestants. One human, one machine's human representative, laughing together over a problem neither of them had solved in time. No medals, no points, just a shared shrug and a mutual "well, that was ridiculous." Math, at its heart, is about connection. Connecting ideas, connecting people, connecting the present to the future. This IMO connected something new, the oldest human intellectual tradition with one of the newest. And that's a lesson both sides will carry forward in their own way. When the last medal has been handed out and the competition hall is quiet, it's easy to think of the IMO as just another event, one more entry in the long list of annual results. But that misses the point. The IMO, like all great gatherings of minds, isn't just about who scored what. It's part of a much larger story. Math has been a human story since before we had the word math. Long before there were printed textbooks, calculators, or server farms full of GPUs, there were people, just people, trying to make sense of the patterns around them, counting sheep, marking the phases of the moon, figuring out the best way to stack stones so the wall wouldn't fall over. Every proof, every theorem, every elegant solution is a kind of letter in a conversation that's been going on for thousands of years. Ancient mathematicians didn't write "Dear future generations" at the top of their work, but they may as well have. When we solve something today, we're answering a question asked centuries ago and leaving new questions for the future. That's why the presence of ChatGPT 5 at the IMO this year felt so strange and, in a way, so fitting. Here was something that wasn't part of that long human chain, at least not directly. It didn't grow up counting sheep or noticing the moon. It learned math from the inside out, by consuming a vast record of what humans have written and solved. It was like a mirror reflecting our own mathematical heritage back at us, but in a different voice. And yet, the AI's solutions, tidy, precise, sometimes brilliant, were still built from the raw material of human thought. Every theorem it used, every technique it applied, came from someone, somewhere, who first thought, "I wonder if this works." If you zoom out far enough, the competition wasn't humans versus machine. It was human thought, past and present, woven together in new ways. The AI didn't replace the human story. It became a new chapter in it. The bigger picture also makes you realize how personal math can be. We think of it as objective. Numbers don't lie. Proofs are either correct or incorrect. But the way we approach it is deeply personal. Some people start with examples. Others dive straight into abstraction. Some like the grind of careful calculation. Others chase the thrill of a sudden insight. Those preferences, those quirks, are part of our individuality as much as handwriting or sense of humor. Machines, for now, don't have quirks, they have algorithms, but quirks are where some of the best discoveries hide. That's why the human element matters, not because we can do things machines can't, but because we do things they wouldn't think to try. Math as a human story is also a story of sharing. Every proof you've ever read was written by someone who took the time to make their thinking clear enough for someone else to follow. That's generosity. It's also vulnerability, showing your steps, knowing someone might poke holes in them. At the IMO, this sharing is distilled into its purest form, strangers from all over the world, solving the same problems in different ways, and then sitting down to compare notes. And now, apparently, sharing space with an AI that never gets jet lag. What's striking is how easily everyone adapted to that. No one stormed out saying, "It's unfair." No one refused to compete. There were jokes, sure. Does it get a free snack if it finishes early? But also curiosity. How does it think about geometry? Does it even picture shapes in its head? The bigger picture isn't fear of being replaced. It's fascination with what we might learn by having both kinds of minds in the same room. In the centuries ahead, math will keep evolving. The tools will change. From counting sticks, to chalkboards, to supercomputers, to whatever comes next. But the core will stay the same. The joy of making sense of something that didn't make sense before, whether it's a child realizing why the pattern in their multiplication table works, or a researcher proving a theorem that's eluded people for decades, it's the same spark. And maybe that's the most important part of the bigger picture. The spark doesn't care if you're made of carbon or silicon. It just wants to jump from one mind to another, lighting up new ideas as it goes. The IMO this year was a reminder that the human story of math is far from over. We're not handing it off to machines and walking away. We're inviting new voices into the conversation and seeing where it leads. And who knows, maybe someday a future contestant, human or otherwise, will look back at 2025 and say, that was the year the story got even more interesting. By the time the last people were drifting out of the hall, the sun had begun to dip low in the sky. The tall windows glowed gold, the kind of light that makes even the most ordinary room look like something from a storybook. The chatter had quieted to murmurs. You could hear the faint shuffle of papers being gathered, the creak of folding chairs, the soft click of a medal case being shut. Math competitions have a strange way of ending. The rush of adrenaline is gone, but the air still feels charged, like the problems themselves are lingering in the corners, waiting to be picked up and solved all over again. People walk slower, as if they're not quite ready for it to be over. In one corner, a group of contestants sat cross-legged on the floor, still talking through the geometry problem from day one. They weren't arguing about points anymore. They were laughing at the ridiculous false starts they'd made, the solutions that fell apart halfway through, the moments they'd almost given up. That's how you know the competition is really over, when the problems turn from battles into old friends you can joke about. ChatGPT 5, of course, didn't linger. It had no suitcase to pack, no friends to wave goodbye to. Its server processes simply stopped running the competition mode and moved on to whatever came next. But its presence lingered in a different way in the conversations about what it could and couldn't do, in the curious glances at the developer still wearing the gold medal draped over one arm. The volunteers started stacking chairs in neat rows, their movements slow and methodical. The stray pencil rolled off a table and clinked softly on the floor. Someone found a forgotten sweater draped over a chair and called out to see if it belonged to anyone. No one claimed it. It would be turned into the lost and found, where it might sit for weeks, a quiet reminder of someone's busy, brilliant day. Outside, the evening air was cool and smelled faintly of rain. Contestants spilled onto the steps, some walking in groups, others standing still, staring at the sky like they were already halfway lost in thought. The Vietnamese champion was talking with the Ukrainian medalist, their heads close together, sketching something invisible in the air with their hands. Perhaps a problem, perhaps a joke, A few coaches lingered too, speaking in low voices about training plans for next year, as if it were just around the corner. In a way, it was. The IMO cycle never really stops. As soon as one year ends, the next begins. One of the older mentors walked past, humming softly. He'd been coming to IMOs for decades, and when asked once why he kept coming back, he said because it's one of the few places in the world where thinking hard is celebrated like a sport. Watching the steps fill with medalists and honorable mentions and tired but proud competitors, you could see what he meant. As the light faded, the hall looked almost empty. Just a few scattered figures still inside, a janitor sweeping, 2 graders double-checking a stack of papers, the developer giving one last wave before disappearing into the evening with a laptop bag and the AI's medal. It felt like the end of a good book, satisfying, complete, but leaving you with the quiet urge to turn back to page 1 and read it again. This year's IMO had been unlike any before it, not just for the problems or the scores, but for the way it had stretched the definition of competitor. The human story of math had gained a new kind of voice, and the conversation would never be quite the same. And so, as the doors were locked and the lights switched off one by one, the math hall went still. Outside, the streets were filled with the soft sounds of an ordinary night. Footsteps, laughter, the distant hum of traffic. Inside, the air held only the faint scent of paper and chalk, and maybe, if you were the kind of person who notices such things, the echo of ideas still swirling, waiting for the next time someone sat down with a pen and dared to solve something impossible. The Math Olympics were over for another year, but the story, as always, was just beginning again.